Okay. And then I'm going to sketch out where I'm going to briefly sketch out where is the I'm just guessing down here. This is pure guesswork. Okay, I'm going to sketch for you where the neutral axis is. So for this case, 1, 2, 3. So this is where the neutral axis is. Okay. Not neutral axis, centroid. So anything you see that is in green, this is a centroid. Okay. Then I'm going to sketch for you another different structure now. Here, the next structure I'm going to sketch looks like this. Okay. And then the last structure I'm going to sketch for you is this. Okay. Then I'm going to draw where the centroid is. Okay. So this is very obvious. This is the center. Over here, over here is somewhere around here. Okay. So the greens are all our centroid. Then I'm going to call 4 points. Okay. So this is alpha, beta. This I will call I, and this I'll call J. Likewise, alpha, beta, okay, I, and J. Okay. Again over here, alpha, beta, I, and J. Okay. Now let me ask you a question. So you have T shape, I shape, and N shape, right? Now, can anyone tell me which one is symmetrical bending? T shape, I shape, or N shape? You can type up your answer. It's okay. T. Anyone else? I. T, I. So it's all the what? All the above, right? T and I. N is not. Okay. I. Okay. That's good. That's good. Okay. A lot of you point at I. Okay. But you know what? Now let me ask you. Okay. If you look at the formula, which one is symmetric bending? If you look at the formula. Okay. So what do I mean by look at the formula, right? So first of all, let me tell you why it's I. Why? Why is this distance? Yes or no? Y can be measured from the centroid. This is Y. Okay. For all the structure, right? Mz is constant. Right? Iz is different, but if I want to find the normal the stresses in the point alpha or beta or I and J, Izz is the same based on the shape. Okay. Now, by looking at the formula, which one is symmetry bending? Looking at the formula, the only variable is Y. Now, you tell me which one is symmetry by looking at the formula. Anyone? I. The answer is or is symmetrical loading. All of them, not I, okay, not P, not N, all of them are symmetrical, okay. You guys, oh, we are confused today. So all of this, all are under symmetrical bending. Why is that? Okay, if you look at let's focus on the I, right? On the T, this distance, y distance, right, is the same for alpha and beta, yes or no? Right? So stress X alpha is equal to stress X beta, right? Because the y is a what? It's a constant, right? Left and right are the same, right? Then stress X in the I direction is equal to stress X in the, sorry, in the I, stress X at point I is equal to stress X at point J, because the y is also what? Constant, right? So the distance from here to here is the same from point I and point J. So if you look at N, right, this distance is also the same for alpha and beta, and this distance is also the same of alpha and beta. So the conclusion is this, right? The conclusion is this. The symmetry bending, let me write down, then we go for a break. The symmetrical bending is based on stress magnitude. Okay, nothing to do with what? Symmetrical loading. Nothing to do with what? Loading and geometry. It all has to do with what? The stress magnitude. Okay, it all have to do with the stress magnitude and, okay, symmetry and one axis of loading of bending only, or bending, and bending is applied in one axis only. Okay, so it took us 1.5 hours to explain what do we mean by symmetrical centric bending. Okay, right, so go for a break. Okay, we come back at 10:45. Okay, then we will immediately do an example. Okay, and then, and as I said, this topic is not as difficult as shearing stress. Okay, go for a break.